Hi there, I'm Bryan, and this video will teach you about simple machine learning with Python. Python machine learning is something I've been exploring for the past few weeks. It is relatively interesting to me how it works and possibilities that machine learning could help to benefit us in our daily life. To put it simply, machine learning is basically taking a set of data, plugging that data into the computer, and having the computer predict possible future data or make specific alterations for specific needs and purposes. For this video, I will be demonstrating the prediction of future grades of students based on past data and information. The data I will be using here was from the internet. This data set includes many data, including school, sex, age, address. But what we'll be focusing on are data such as study time, failures, absences, and G1, 2, and 3. These mean the grades of 3 separate tests: test 1, test 2, and test 3. What we are attempting to do is to use the grades of test 1 and test 2 to predict the grade of test 3, along with other factors. Ignoring the input commands, which are basically installing the correct packages, data, this basically imports the data from the file, and semicolon means that each data are separated by semicolons. Here we are taking the data that matters to us, which is G1, G2, G3, study time, failures, and absences, and we are trying to predict G3. X is our input, which includes everything other than G3, and Y is our output, including only G3. These 4 variables represent values that we'll be using in our operation and calculation and testing of our machine learning code. This means that we are using a linear regression. Basically, we are trying to make a linear formula for this set of input and output. Basically, we're trying to find the line of best fit. Remembering back to a 2D graph where the formula of y equals mx plus b gets us the line of best fit, or the equation for a linear line. This is what we're trying to do, only that we're not using 1 input and 1 output, rather 5 inputs and 1 output. Here, we are printing the accuracy. Basically, we are showing how accurate our data is. And then we are also showing us the slope coefficient, which there's 5 of, and also the intercept to make it more visual and clear to us, the programmers. And then finally here, we are predicting the predictions, the actual set of inputs, and the actual grade for test 3. And then we're looking to see if our prediction and the actual grade for test 3 are similar. Note that here, there's something such as test size equals to 0.1. This means that while 90% of our data will be used to train the machine learning code, only 10% will be used to actually operate it, which is shown here. If you run this code, which will take a while, you'll see that here the accuracy for this run is 74%, which is relatively low. The slope coefficient and intercept are displayed here. And then the actual predictions. As you can see, 12.3 and 13, they're relatively close. 9.6 and 10, also relatively close. 7 and 8, 15, 15, 12, 12. However, some of the more distinct ones are such as this, 7.2 and 0. Let me find another one. 3.7 and 0. 7 and 0 again. This basically shows us that although there are many cases of correct outputs or relatively similar outputs, there are also ones that are way off, which accounts for the 74% accuracy. Moving on to a more advanced version of our code. You can see here that the input code has been expanded because we're using more commands. Basically, what's changed here is different from the previous one, where for each run, we have to run the machine learning. We have to basically teach the machine separately. So if you want to run it 10 times, you have to teach the computer 10 times. And each time there will be a different accuracy. It may be higher or it may be lower. For this, we are basically saving a specific run into a pickle file. Basically, if we run this pickle file, or if we run the data with this pickle file, it will automatically use the accuracy and formula of the pickle file. So we don't need to run the test again. Without the commenting. So, such as this, if you run this, it'll create a separate file, .pickle file, and then it'll save this run of 79% accuracy into the pickle file. So if we were to comment this out, and run it again, notice that we're not showing the accuracy, we're not running it again. However, it's not showing accuracy, however, we are still able to run it because we have run it with the pickle file. Moving on to an even more advanced version of the code, you can see here that something that has changed is a for loop that has been added. Basically, what this does is it runs the code 30 times. It basically teaches the machine 30 times, and then it gets the highest accuracy run out of all 30 runs, and then it saves that as the pickle file. This is more efficient because we can basically train the machine to have the highest percentage run and then operate all our data off of that run, which makes the efficiency and the accuracy improve drastically. This can be changed from 30 runs to 100 or even 20,000, although the time that it takes to run each run will take significantly longer. However, if we were to make it not common, so it actually runs and run this code, we'll see that it takes a longer time for it to operate. However, it gets this one, which is relatively accurate. 9.5, 10, 10 to 0.2, 12. If we look closely, we can see that there's almost no data that differs too much from our original. At most, 1.5 difference. But yeah, and 3.6, this may be an outlier. But other ones, there's not much difference anymore. Finally, we are moving on to the last version of this code. You can see that there's not much changed here. Rather, there's a visualization part. Basically, what we'll do is if we run this, it'll make a graph and it'll plot the value of G1 against a final grade. As you can see here, what the computer did is it basically found the line of best fit through all these data points, and it calculated the formula for this line of best fit. And then to predict other data, the computer basically used that formula and used the inputs, and it calculated the output. What's interesting is if we change this now from grade 1 or grade 2 to something, say, failures, we get a more visual representation of the relationship between failures and the final grade. So here we can clearly see that with less failures, we have a higher final grade, and with more failures, we have a lower final grade. In the end, this has been a very good side project for me, and I have learned a lot of Python machine learning from this set of tutorials, both formed from YouTube videos and from online sources such as W3 Schools. I hope that with this video, you also learned more about Python machine learning and hopefully, you can even create a code of your own. Thank you.